Have you ever wondered how transistors work? It's a question that might seem daunting at first, especially for those of us who aren't exactly tech wizards. But the reality is, transistors are everywhere. They're like the unsung heroes of our modern world, working behind the scenes in almost every piece of technology we use. From our smartphones and laptops to our televisions and gaming consoles, transistors are the building blocks that make these devices possible. But what exactly is a transistor? Think of it as a tiny switch that controls the flow of electricity within a device. But it's not just a simple on or off switch. Transistors can control the amount of current flowing through, making them incredibly versatile and essential in creating complex electronic systems. By the end of this video, you'll understand why transistors are integral to your everyday devices. So buckle up and get ready for an exciting journey into the world of transistors. In simple terms, a transistor is a switch. Imagine walking into a room and flicking a switch to turn on a light. The action of your finger is analogous to the role of a transistor in an electronic circuit. Just as your finger controls the flow of electricity to the light bulb, a transistor controls the flow of electricity in a circuit. But let's dive a little deeper. A transistor is not just a switch, it's a tri-terminal device. That means it has three parts: the emitter, the base, and the collector. Picture these three parts as if they were 3 points on a triangle. The emitter, as the name suggests, emits or gives out charge carriers. These can be either electrons or holes, depending on the type of transistor. The base, the second point on our triangle, is a thin layer sandwiched between the emitter and the collector. The current applied to the base controls the transistor. Now let's talk about the collector, the final point on our triangle. The collector collects the charge carriers emitted by the emitter. So you can think of the collector as the end point, where all the action culminates. But how does a transistor work as a switch? It's all about controlling the current. A small current at the base controls a larger current that flows from the collector to the emitter. When the base current is zero, the transistor is off, just like a light switch in the off position. But when the base current is applied, the transistor turns on, allowing a larger current to flow from the collector to the emitter. So in essence, a transistor acts as a gate, opening and closing to allow or restrict the flow of current. It's a marvelous piece of technology that has revolutionized the world of electronics. Just like a light switch controls the flow of electricity to a light bulb, a transistor controls the flow of electricity in a circuit. So how does a transistor control the flow of electricity? That's a question many have asked and one we're about to answer. Picture a faucet controlling the flow of water. A little twist and the water gushes out. Another twist in the opposite direction and the flow slows to a trickle. This is quite similar to how a transistor functions, but instead of water, we're dealing with electricity. A transistor is composed of three parts: the collector, the base, and the emitter. The collector and emitter are like the inlet and outlet pipes of our faucet analogy, and the base is the handle that controls the flow. But how does it actually work? Well, let's dive in. The key here is to remember that a transistor operates on the principle of using a small current to control a larger one. This is where the base comes into play. When a small current is applied to the base, it acts like the handle of the faucet, opening up the path for a larger current to flow from the collector to the emitter. In other words, the base current is the boss here. It determines whether the transistor is on or off. When there's no current applied to the base, the transistor is off, blocking the flow of electricity. But when a current is applied to the base, it's like turning the handle of the faucet. The transistor turns on, and a much larger current flows from the collector to the emitter. This ability to control a large current with a smaller one is the essence of a transistor's function. It's this principle that allows us to amplify signals in radios and televisions, switch electronic signals in computers, and regulate power supply in various devices. So in essence, a transistor gives us the power to control and manipulate the flow of electricity in an electronic circuit, just like a faucet controls the flow of water in a pipe. A transistor then is like a faucet for electricity. Where can you find transistors in action, you may ask? The answer is quite literally everywhere. These tiny devices are the unsung heroes of our modern world, silently and efficiently controlling the flow of electricity in virtually every piece of technology we use. Take your mobile phone for instance. It's not just a device for calls and texts. It's a mini computer, a camera, a GPS, a music player, and so much more. How does it manage to do all this? It's all thanks to millions of transistors. They are the ones that make it possible for your phone to process information, run applications, and connect to the internet. Transistors function as a sort of gatekeeper, regulating the flow of electricity through the circuits. When a certain voltage is applied to the transistor, it allows electricity to flow through. This on and off switching is the fundamental process that powers the binary language of computers. Now let's consider your computer. It's a marvel of technology, capable of complex calculations, rendering stunning graphics, and connecting us to the vast digital world. The central processing unit, or CPU, the brain of the computer, contains billions of transistors. These transistors work together in harmony, switching on and off billions of times per second to execute the instructions that run your programs and applications. Transistors also play a crucial role in other electronics, like your television, your car's engine control unit, and even the microwave. In each of these devices, transistors control the flow of electricity, ensuring that the right amount of power is delivered to the right components at the right time. In essence, transistors are the building blocks of modern electronics. They're the tiny switches that make our devices smart, capable, and efficient. They're the unsung heroes that make our digital age possible. Without transistors, our modern world would look very different. So, the next time you use your phone or computer, remember the billions of transistors working tirelessly behind the scenes, making all of it possible. What's the relationship between a diode and a transistor? Well, to put it simply, we could say that a transistor is a diode's big brother, a more evolved, more complex version of it. Let's start with the basics. A diode is like a one-way street for electricity. It allows the electric current to flow in one direction but not the other. Picture yourself driving on a one-way street. You can only move forward, right? There's no turning back. That's exactly how a diode works. It's a device that controls the direction of the flow of electricity, ensuring it moves from the positive side, called the anode, to the negative side, known as the cathode. And just like you can't drive backwards on a one-way street, electricity can't flow from the cathode to the anode in a diode. Now, let's bring in the transistor, the star of our show. A transistor is like two diodes put together. But it's not just about doubling up, it's about controlling the flow of electricity in a more complex way. Imagine a busy intersection in a city. There are multiple paths, multiple directions in which traffic can flow. But without a traffic signal or a traffic cop to control the flow, there would be chaos, right? That's where the transistor comes in. It's like the traffic signal or the traffic cop at the intersection. It controls the flow of electricity, deciding when and where it should go and how much should pass through. The transistor has three parts: the emitter, the base, and the collector. The emitter emits the current, the base controls it, and the collector collects it. It's a bit like a team, working together to control the flow of electricity. So in essence, a diode and a transistor are both about control. The diode controls direction, while the transistor controls not just direction, but also the amount and timing of the flow. A transistor is like a sophisticated traffic system controlling the flow of traffic, or in this case, electricity. Let's wrap up everything we've learned about transistors. These tiny devices, often no bigger than a grain of sand, are the unsung heroes of our digital age. They form the backbone of modern technology, playing a crucial role in everything from your smartphone to your car's engine. We've understood that transistors are essentially switches for electricity, controlling the flow of current through a circuit. When a small amount of current is applied to the middle layer or the base, it controls a larger current flowing from the emitter to the collector. This simple yet ingenious design allows for the complex operations we see in our digital devices today. In addition, we've explored how the humble diode, a component that allows current to flow in one direction, is a key component in the functioning of a transistor. Next time you use your phone or computer, remember the tiny transistors working behind the scenes to make it all possible.